In the previous video, we went ahead and discussed statements, white space, and indenting. It's now time to move on to the if keyword and also discuss code blocks in more detail. So as you can see, I've created a new project. I've called it if keyword and code blocks. So what I want to do first is just go through the if keyword a little bit more so you're familiar with various ways that you can actually use it. So what we're going to do is create some code and then go through it. So I'm going to start with some code. I'm going to delete that comment and put Boolean game over equals true, int score equals 5,000, int level completed equals 5, int bonus equals 100. So we can use the if keyword to create a statement something along the lines of if score equals double equals, because we're doing a test, equals 5,000. We can use the brace to create a code block, and we can put something like print your score was 5,000. Okay, so we can just run that. So as you can see, the if statement was pretty basic and it printed out your score was 5,000. Just making more space here. So that's the first use of the if that you've seen, but we can actually also do this. We can get rid of these braces, in other words, get rid of the code block, if we've only got one line, one statement that we want to get executed after the test. So in this case, if score equals 5,000, if that's true, it's going to run that and execute that like you just saw me run. If that's not true, it's just going to ignore that and go on to the next line. So again, we can run it just to confirm that it's going to work. We still get the same response. We still get the score was 5,000. What we can't do without the code block, without adding the braces, is we can't put another line here, because what happens as you'll see, we run that again. This was executed as well, but if we change this if so that it's 4,000, and of course we've set the score to 5,000, so we shouldn't see your score was 5,000 on the screen now because the comparison will fail. But the output this was executed was still executed. So what's happening is that this is being executed no matter what, because it's not on the line after the if test. And that's because only one line without a code block, without adding these braces, we can literally only process one line at a time. If I add the braces, so in other words, if I create a code block and put that code in there, then that will quite happily work. We run that. Then we get no output because, of course, the score isn't 4,000, it's 5,000. And if we change the comparison so that it's 5,000, we get both because it's actually in the code block. So the use of code blocks are optional if you've only got one statement you want to process. What I generally recommend is, even if you've got only the one line, to probably use a code block anyway. And that's because I believe it actually makes the code clearer and easy to understand. So removing the code block, just sometimes at a glance, if there was a space there, which Java accepts, sometimes you might get a little bit confused at first glance and wonder whether this is all part and parcel of the same, if keyword statement, if you will. But the other thing you can do, I'm going to put the code block back now. Let's change this around a bit. I want to show you some of the other parts of the if, which I know we've talked about a little bit, but just to make it a little bit more clearer. So we can put something like if score is less than 5,000, your score was less than 5,000. What we can also do is put an else, and put a code block. So what will happen there, we can put something like got here, just to see what happens. And if we run that, we got here, and the reason that we got here, we didn't see any other output, is the first if test was checked. So is score less than 5,000? No, it wasn't. So this line, this code block, was not executed as a result of that. So what happens then is the computer goes on to the next part here, which is an else statement. And because we've got no other condition there, it says, okay, in all other circumstances, I'm going to just print got here. And that's why it printed got here. If we then change this to put less than or equal to 5,000, we get the message your score was less than 5,000 And now the else wasn't executed, so this line didn't get executed because the first condition was fulfilled. So you can see that the if is useful from that scenario, but we can even expand it further. What we can do is we could put something like, so we'll do that test if it's less than 5,000. But we can also do something like else if score is less than 1,000. Create another one, and I'll change that so it's less than 5,000. Then we'll use and greater than 1,000. And we can put this here, your score was less than 5,000, but greater than 1,000. Then we can put else if score is less than 1,000, we can put some output. Your score was less than 1,000. I need to put a variable name in there, score. So now what will happen is if the score is less than 5,000, but it's greater than 1,000, it's going to print that message. Else if the score is less than 1,000, the score is going to show that message, your score is less than 1,000, otherwise it's going to go to got here. So let's try and see what happens there. Got here was executed because of course these first two lines aren't processed because in both cases the comparison tests there have failed. So score is 5,000 and score is greater than 1,000. What's in either of those scenarios because score is currently set to 5,000. We could change that to check that it's working by making that 4,000. So if you run that, your score was less than 5,000 but greater than 1,000. So it's now executed this first component, and you can see that it's automatically jumping out of the section after it's executed something. So as soon as it's found something, it's going to ignore the else if and any other subsequent else's along the way. And just to confirm that, we can then make the score to be 800 and run that. We've now got your score was less than 1,000, as you can see there. So that's only executed this section here. So this can be very useful to use the if keyword to build up statements to test a lot of scenarios and to proceed and execute certain code based on what the results of those comparisons were. So that's the if keyword. I hope that's given you a bit more clarification. So let's now just take it to the next level. What I'm going to do is highlight that code. I'm just going to comment that out. Now on a Mac, I can hold down Command and press slash. You could also have gone up to the code menu and selected comment with line comment. And you can see to the right, there's the command slash is the keyboard shortcut on a Mac. So check that out on your operating system to see what the shortcut is. So what we want to do is we want to do a test here. We want to put if game over equals true, int final score equals score plus level completed times bonus. We want to print out your final score was final score. So if you run that, we can see that the final score was 1,300, and that's because the final score equals the score, which was 800, plus level completed, which is 5, times our bonus, which is 100. So therefore it's 800 plus 500, and the final score was 1,300. So you can see that the code block, as we've done before, was executed because game over, of course, was set to true. But notice how we've created a variable in the code block. And the thing to remember about code blocks is, as you can see here, they're able to access variables that were created outside of the code block. So you can see that we've accessed score, as you can see score there, level completed and bonus. All these variables were created outside of the code block, but final score was created, the variable, inside the code block. But what we can't do is we can't put something like this, int saved final score equals final score. And IntelliJ comes up with an error and it says cannot resolve symbol final score. And that's because once this section of code has finished, in other words, the computer has processed it, it will automatically delete any variables that it creates in that code block. So the reverse isn't true. While you can access variables created outside of the code block, in the code block, what you can't do is access variables created in the code block outside of the code block, as you can see in this scenario there. And just as another abbreviation, you can also, where you see something like this, game over equals true, that can be abbreviated to if game over. So that essentially is exactly the same as typing if game over equals true. So keep that in mind as a way to abbreviate your code. You'll see that commonly used in Java code. There's just a shortcut to just test to see whether game over has the value true. So this concept of variables inside a code block is called scope. And scope is something that requires videos in its own right. We'll be talking more about scope in future videos. And scope really deals with accessibility of variables in certain situations or in certain places in the code, for example, a code block. The bottom line for now is in a code block, if you create a variable, you can't access that variable you've created outside of that code block. But of course you can, as you saw, still access variables that were created previously and prior to going into the code block whilst you're in the code block itself. Okay, so it's challenge time. Okay, so the challenge for you now is to create a second printout on the screen, this time with the score set to 10,000, with the level completed set to 8, and with the bonus set to 200. So you need to do something very similar to what we've done here in this first example, but you need to also make sure that this still displays, so that essentially you'll have this first one displaying. You'll then below that have a second line with the scenario here also displaying, and both of them should be displaying here in the right hand corner. Alright, so go to it, pause the video, and go ahead and see if you can implement that. And when you're ready, start the video again and come back and see my solution. So how did you get on? Did you figure it out? Well, there's a couple of ways to go about this. What we could do, the first approach would be to create a complete new set of variables and to essentially do a copy and paste of that code, but use all the new variable names. So that would work. We could do something like copy, and we'll call this new game over, new score, new level completed, new bonus. And then we could do something like, and I could do something like new score equals new level completed times new bonus. And note how I can still use the int final score in this second code block, because if you remember, as soon as the code block is finished, Java will automatically delete that. So that's why we're able to recreate another variable with the same name again. Of course, we weren't able to do that with these variables because they're in the same scope, effectively in the same part of the code. And the other thing I need to do is change that game over to new game over. So we could do that. If we run that, you'll find we've got, whoops, new score was meant to be 10,000. I didn't change these, did I? The values 8 and 200. That was what we were looking for. So we run that again. Get the answer 11,600, which is 10,000 plus 8 times 200 is 1,600. 10,000 plus 1,600 equals 11,600. So that's certainly one solution to it, creating all new variables. The disadvantage with that approach is you're using excess memory, so you're creating new variables that you don't potentially need. So what you could do as an alternative, we could have just reused those variables again. So what we could have done is, I'm just going to comment that code out. I could have just copied these. This time I'll get rid of the definitions because we're not redefining them. We're just changing the values. So we can make that 10,000, level 8 and 200. And then we can literally just copy and paste this section of code again. Paste that in because it's exactly the same. We're using the same variable names. Everything else should be the same. So we should get the same output here. So we run that. So that's another way of doing it. That's just literally copying and pasting. The advantage with that approach is it was quicker. We didn't create new variables, so we used the memory more efficiently. But the disadvantages, firstly, we haven't got a permanent record of these variables. So if we wanted to keep the fact that this first score was 800 and the level completed was 5 and bonus was 100, we can't do that because we've now redefined the variables. Secondly, we've used game over equals true for both. And if you were tracking two players' scores, maybe game over was only the case for one of them. So in this case, you may not have actually printed this out at all because it was set to false. But the other disadvantage is we're copying and pasting code. And the disadvantage with copying and pasting code is we're duplicating code. And what that means is if we need to make a change, then what we need to do is change it in more than one place. And if you forget that your code has been duplicated, you may forget to change it in one place, which means your scores may not be calculated correctly. For example, let's just say we've decided to change the formula for defining our final score, and we're going to add a bonus of 1,000 to the final score that was calculated. So we come along here and we put plus. So just on the next line, we could put final score plus equals 1,000. So that was an overall final bonus. So if we run this, you can see the first score was correctly set to 2,300, which was the 1,300 plus the 1,000 bonus. But down here, we forgot to make the change in this particular code block. And as a result, that final score didn't have the final 1,000 points added to it correctly. That's the disadvantage with duplication. You need to go back and remember all the places where the code is duplicated and to make your change. So you're really asking for errors in the long term because, let's face it, we're all human. We make mistakes, we forget things, and it is very common in programming, particularly as the code you work on gets more complicated, to forget, if you're duplicating a lot of code, where all that code is. So you definitely don't want to get into that scenario of duplicating your code. And there are lots of ways to help really reduce or eliminate the need pretty much for any duplicate code. So in the next video, I'm going to expand on from this example and show you how you can remove duplication by using the concept of methods. So methods is taking the concept of a code block to the next level, and it's going to effectively allow you to reuse that code. So type the code once and reuse it multiple times. So we'll do that in the next video.